Okay, number 33. Let's take a look at this up close. The domain goes, well, if you can see the arrow here, that indicates that it keeps going in that direction, in that general direction. So it goes to the left to infinity, right? So the domain goes from negative infinity all the way up to x equals 1, and you're including 1. So negative infinity to 1 is the domain right there. Remember to use parentheses next to the infinity symbols, plus or minus, because those are not real numbers. Infinity is not a number. And so you're not including that in the interval. Okay, and then from the range goes from y equals 0, right there, y equals 0, and this function keeps going up, up, up. So from 0 to infinity, right there is your range. And number 35. This one is probably a rational function. You've got a vertical asymptote here. You'll learn more about rational functions and their graphs later. But when x equals 0, as you can see, the function doesn't exist. Okay, so that's not going to be in the domain. But going from the left to the right, it looks like it goes from, let's see, are we including that point? There's a dot, if you can look closely, there's a dot there at x equals negative 6, so that's where it starts, and it keeps going. Well, it's not an asymptote really, is it? It just stops right there. It stops right there at x equals, well, just shy of negative 6. So, in fact, or x equals negative 1/6, there it is, negative 1/6. So it goes from negative 6 to negative 1/6. So this is just a piece of a rational function, not the whole thing. And then it goes from positive 1/6, x equals 1/6, all the way to positive 6, as you can see from these points. So the domain is negative 6 to negative 1/6, and then the union of that with 1/6 to 6. And as for the range, the lowest point would be where there it says negative 6, and it goes all the way to y equals negative 1/6, as you can see it red there. And then it starts again at positive 1/6 and goes up to 6. So the range goes from negative 6 to negative 1/6, union 1/6 to 6. Okay, number 37. So we zoom in on this here. The domain starts at, well, these go by 2's here, 2, 4, 6, 8, and so on. And so in between, that looks like it's exactly halfway between negative 2 and negative 4, the x value. So that would be negative 3. And x goes all the way, well, it keeps going, doesn't it? That arrow means it keeps going. So it starts at negative 3 and it keeps going to infinity. So there's our domain right there. And then for the range, the y values start at y equals 0 here. And they go up, 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 don't they? right? So the y values just keep going up because of that arrow. So it starts at y equals 0, goes to infinity, and that's your range. Okay, number 39. We have a piecewise function. The directions say, for the following exercises, sketch a graph of the piecewise function. Write the domain in interval notation. Okay. So I've already drawn a set of axes on here. Now if you're not used to drawing these, you might want to try something like this. This may help you to draw this. You look at where the domain gets split up between the different pieces of the function. It apparently splits up at x equals 1. So you could draw a set of a vertical dotted line going through x equals 1. And that's meant to indicate it's not part of the graph, but it can be erased. So if you're using a pencil, which you should on these, you draw it lightly so it's easy to erase later. Okay, so y equals 2x minus 1 if x is less than 1. Alright, so just draw the line y equals 2x minus 1. But when you go past x equals 1, this dotted line, go to the right rather. When you're in this area here, that belongs to this piece of the function, not 2x minus 1. So you would draw it lightly with dotted lines, so you could erase it later. But 2x minus 1, that's in slope-intercept form. Slope is 2, y-intercept is -1. So you put a dot at -1. Oops, that's not -1. That's not -1, that's +1. Alright, let's get that back in there. Since I don't have a pencil that I can use, it's a little harder to erase on this. So at -1, okay, y equals -1. The slope is 2, +2. So slope m is rise over run. Okay, so if you have a slope of 2, that means you have a rise of 2 over a run of 1, or it could also be thought of as -2 over -1. Either way, if you look at it this way, +2 over +1, that means you go from this point, you have a rise of +2, so you go up 2 units on the y-axis, and a run of +1 means you go to the right 1 unit, right there. Now you cannot include that point because for this part of the graph, that applies if x is less than 1. So you can't include x equals 1 here. Okay? But anyway, you can connect these two circles or 2 dots with a straight edge. You really don't need to separate it here, but you can connect the dots and draw your line. If you look at it this way, -2 over -1 as a slope, that means a rise of -2, start at the y-intercept, go down 2 units, 1, 2. And a run of -1 means you go to the left 1 unit. And you could put a dot right there and connect the dots as well with a straight edge. So if you extend the line all the way, you would draw it like this on your paper. Like that. And then you would erase this part right here. Now, I've mentioned this before, you can get what are called eraser shields. Here's one I used when I was in high school drafting. It's made of aluminum, lasts forever. And you can notice it's got various holes in it. You can cover parts of your paper and just erase the parts that you want to erase without touching the other parts. Okay, so I believe you can still buy these. But yeah, I used that in high school drafting, back when it was not computer aided, back in the late 60s, yeah. So it's a great tool for mathematics. I've always used them in math. But you can erase this part if you've used pencil or erasable ink. Erase that, and there's part of your graph. And then y equals 1 plus x. Another way to write that would be x plus 1. That's the usual way we write that, slope-intercept form. So it's got a slope of 1x, and a y-intercept at 1. So you put that in there, and you would have to erase that if you mark that. Alright, but so I'm just going to remember that. Put a little dot there. And the slope is 1, so you could consider that as 1 over 1 or negative 1 over negative 1. That also equals positive 1. So it's probably better if we use 1 over 1. So you, because we're going to the right here, okay, so everything to the right here has to do with y equals 1 plus x. That's x greater than or equal to 1. So we go up 1 and to the right 1, and we fill in that dot because we're including that x equals 1, because it says over here if x is greater than or equal to 1, you use this function. Okay, so you can connect the two dots with a straight edge and just draw this part. Like that. Alright. So that's generally how it should look. I'm not using a straight edge, and I'm not using a pencil, and it looks sloppy. So, you know, you want to use a straight edge with this, but there you go. And the domain in interval notation, well, it goes to the left all the way to negative infinity. And right here is the only problem you might run into, but it does include x equals 1. It doesn't stop with the x values, so it goes all the way to the right to positive infinity. So the domain is from negative infinity to infinity. And that's it. Okay, number 41. F of x is 3 if x is less than 0. Square root of x is if x is less than or greater than or equal to 0. Okay, so it's 3 if x is less than 0. So you're not including x in this part of the function. Alright, you're not including x equals 0, that is, in that part of the function. So you would put an open circle at x equals 0, and at this point you would just put y equals 3. So open circle here, like that. Alright, now it equals 3 if x is less than 0. So it's always going to be 3, y equals 3, no matter what the x value is to the left of 0. So you would just plot that as a horizontal line. Right, like that. And it keeps going like that. Okay, so whatever point you have on this line, the coordinates are going to be x3. Alright, x3. The y is always going to be 3 on there. So now, if x is greater than or equal to 0, it's square root of x. So you're including x equals 0 on this one, on this part. Square root of 0 is 0, so you start here at 0, 0. And the square root function, you should know pretty much what it looks like. Look in your toolkit functions, square root functions in there. You've drawn this before as well, probably. So the way you would draw this is get a couple of points that you know and kind of draw a rough shape, the rough shape of it. For example, when x is 4, the square root of 4 is 2. So you would put that in there, 4, 2. Connect the dots with a curved line. And it keeps going. Alright, kind of like that. And the domain, it keeps going all the way this way toward negative infinity, and it keeps going all the way that way toward positive infinity. There's no interruptions because x equals 0 is included. So the domain goes from negative infinity to infinity. That's it. Number 43. We have f of x equals x squared if x is less than 0, and x plus 2 if x is greater than or equal to 0. So to the left of 0, it's x squared. Alright, that's a parabola opening upward. So when x is 0, y here, if you plug 0 in here, it's going to be 0, but you're not including that point on this part of the graph because this only applies for x less than 0. But that's a starting point that you need, so you put an open circle at 0, 0. Alright, and now everything to the left of x equals 0 is y equals x squared, so it's basically half of the parabola, the left half. So I'll mark when x is negative 2 squared is positive 4. That will be on the graph. I'll put another dot there at negative 2, 4, and then I can connect those with a parabola shape. And remember, when you draw the parabola at the vertex at the very bottom, it doesn't come to a point. It doesn't look like this. Alright, that's not the parabola. There's no sharp points in the parabola. Okay, it's all nice and smooth. So, you may not think it's a big deal now, but when you get into calculus, you'll see, and you'll use calculus, and you can prove that it doesn't come to any sharp points at all, anywhere. Alright, but we won't get into that now. But get into the habit of don't make that a pointy vertex there. Alright, that wouldn't be correct. And what else do we have? Okay, we've got y equals x plus 2 if x is greater than or equal to 0. So this is in slope-intercept form. The slope is 1, and the y-intercept is 2, and we're including x equals 0. So when x is 0, y equals 2. That's the y-intercept. So we put a solid dot there, a solid circle. And now we use our slope. Okay, so everything to the right is y equals x plus 2, the right of the y-axis. Okay, so the slope is 1, which means rise over run. One over 1. Or you could write that as negative 1 over negative 1 if you wish. But in this case, it doesn't really help us to do it that way. I'll show you why in a second. Alright, so we use 1 over 1. Slope is 1 over 1. Rise over run. Rise of 1, so you go up 1 from the y-intercept. And a run of positive 1, you go 1 unit to the right. And you put another dot there, connect the dots with a straight edge. Stop right there at the y-axis. Okay. Again, this applies only if x is greater than or equal to 0. So you don't want anything filled in to the left, or if you do, erase that part. Okay. Now, to use this slope, -1 over -1, you would start at this y-intercept. Rise of -1 means go down 1, and run of -1 means go to the left 1. All right. So you could put a dot there, but it's not included in this graph, so it doesn't help us. But if you were drawing this in some other graph, it might be better if you use that. So for example, if your y-intercept is way down, well, let's say way up here, all right, and you run out of space to go to the right and up, well, then you would use this one. You would go down and to the left, and you'd still have a lot of space for that, okay, and you could draw another point and connect the dots that way. So sometimes it helps to use the negative over the negative. Now if the slope were negative, for example, if the slope was -1, you could write that as -1 over +1, or +1 over -1. Okay, both of those are equivalent to -1. So a rise of -1 means you go down 1, and then a run of +1 means you go to the right 1, down 1 to the right. On this one, a slope of 1 over -1, the rise would be +1, means you go up 1 unit, and then the run of -1 means you go to the left, so you go up and to the left. All right. So again, those might help you in certain contexts. Oh, and the domain, let's check that out before we move on. It keeps going here. Let's put that arrow in. It keeps going to the left, and it keeps going to -infinity on the left, and it keeps going to the right, +infinity. And there's no breaks, no discontinuities, as we say, at least in the domain. All right, so everything's in there in the domain from -infinity to infinity. So there you go. There's your domain. Number 45. So we have f of x is absolute value of x if x is less than 2, and f of x equals 1 if x is greater than or equal to 2. So in other words, y equals 1, that's a constant function. It doesn't change. That's what they call a constant function. And it's a horizontal line. Okay, but anyway, let's go to this part. If x is less than 2, let me divide up my interval here. When you get used to doing these, you don't really need to do this. But if you're not used to it, it might help you to see where to start and where to stop with these. You'll have to erase that later. So, if x is less than 2, it's absolute value of x. What if it equals 2? Well, I know that's not part of it, but let's assume it does, so we can have a starting point and draw an open circle there. Okay, so when x equals 2, absolute value of 2 is 0. So we have the point 2, 0, or rather 2, 2, what am I talking about? The absolute value of 2 is 2, so when we got the point right there, draw an open circle at 2, 2. Alright, so that's part of this graph, or not part rather, so it's got an open circle, but that's our starting point. And then you can fill in other points, but if you remember that absolute value looks like a V with the vertex right there at the origin, you could just draw a V in, connect these 2 points with a straight edge, and then extend it to the left, another V. Be sure that you include these points, -1, 1, -2, 2, and so on. Alright. So when x is -1, absolute value of -1 is 1, so you got -1, 1. When x is -2, absolute value of -2 is +2, so you have the point -2, 2, and so on. So that keeps going to the left. And then if x is greater than or equal to 2, y equals 1. Okay, so now we're including x equals 2 here, so I'm putting a solid circle here. And it's just a horizontal line like that. Keeps going. So for any point on this part of the graph, let's say right there, any point whatsoever will have the coordinates x, whatever x is, and y equals 1. Okay? No matter what x is, as long as it's greater than or equal to 2. Okay? So the y equals 1 is just a horizontal line. And the domain, it goes all the way toward negative infinity to the left, and it goes all the way to positive infinity on the right, and in the domain, as far as the x values go, there's no discontinuities, no breaks, because positive 2 is included there, x equals positive 2, even though it's not here. It's included in the function here. So the domain goes from negative infinity to infinity. Number 47. Here we're given a piecewise function and we have to evaluate it at different points, f of negative 3, f of negative 2, f of negative 1, and f of 0. Okay, so f of x is 1 if x is less than or equal to negative 3, and 0 if x is greater than that. So the first one is f of negative 3. So if x is equal to negative 3, that does not fit, but this does, all right? This is less than or equal to. So y equals 1. In other words, f of negative 3 is equal to 1. Okay? F of negative 2. So if x is negative 2, where does that apply? Here? Well, no, negative 2 is not less than negative 3, and it's not equal to negative 3. So here it is, right? Negative 2 is greater than negative 3. So that means y equals 0, or f of negative 2 equals 0. And f of negative 1, when x is negative 1, it's obviously that's obviously greater than negative 3, so y equals 0. Once again, and f of 0. So when x is 0, that would apply here. 0 is greater than negative 3, so y equals 0. There you go.